2 years ago at this forum, I presented a talk entitled it From Flesh and Bones to Bits and Bytes. And I like this title because it was kind of a cool combination of words, but it meant to represent something which I think is pretty important, pretty transformational. What it's saying is that a physician, through a telemedicine interaction, is now not interacting with the flesh and bones of the patient, but that physician is now interacting through a technology interface and is actually interacting with a digital representation of that patient. Furthermore, that technology interface is connected to a computer. Furthermore, that computer can be connected to a cloud. And, a bunch of the talks over the course of today kind of reference this concept, but not directly mentioning it, and how artificial intelligence and other things like that can be applied because this architecture exists. So this is, I think, an important new paradigm. And what I did in my talk a couple of years ago is I actually tried to make the case that in the future, that perhaps a telehealth interaction is actually not inferior, but perhaps even equivalent, or in some cases superior, to a face-to-face in-person interaction. I think, the standard of care, and I think it's probably still the point of view today, that if you can get face-to-face in person, that's the best way to deliver care. But if you can't, you go for second or third best. Telehealth is a way to do that. And I'm trying to actually dispel that notion and the fact that telehealth as being inferior, it actually may not, especially as things move forward. And I'm going to, hopefully through this talk, further apply examples where that makes that point. Last year, I gave a talk. It was titled, "The Network is the Hospital." So again, the network is the hospital? That's kind of weird. The hospital is the hospital. But what I did is I leveraged off this tagline that Sun Microsystems had in the 1980s, and I was a computer engineering graduate student at the time, and they had a slogan. It said, "The network is the computer." And I remember thinking to myself, what do you mean the network's the computer? The computer's the computer, the network's the network. But they were actually very forward-thinking, and what they were really saying is that a networked computer system, in a networked computer system, the power is actually the network. The computer powers it, but the power is in the network. And we know that can be true if we take any of our computers and we turn off the network or unplug it from the network. I think we would all agree that the power of that computer has now diminished more than 50%, proving the point that the network is the computer. And now I'm taking that same concept and I'm saying, if you think about healthcare, and when we think healthcare, we often think hospital, but then if we attach a network, as in a telehealth network, to that hospital, I think the concept is that the future of healthcare delivery is really in that telehealth network. It's powered by the hospital, but it is actually that network becomes really the power of the overall system. And then furthermore, if you connect all the different hospitals and all the different health systems in the country, in the state, in the county, in the world, you actually now have the ability to bring all of those resources to bear anywhere across that network, wherever it might be. So these are two different paradigms I'd like to play on through the rest of my talk. So one, we've got a digital representation of the patient, and two, we've got a network delivery system, and then that leads me to this year's presentation. And in this year's presentation, I titled it Telehealth, a New Platform for Physician-Led Innovation. So with these two paradigm shifts based around telehealth, I'm going to be hopefully showing you how, with the right expertise, we can make this go to places none of us can even imagine. So before getting into more of the details of the talk, let me just start with a little bit more on the telehealth network. When you think about a telehealth network, I think what we mainly think about today is just the ensured reliability connectivity so you can connect physicians or clinicians and patients wherever they are. In the future, that's table stakes. That obviously has to happen, but that's actually not anywhere close to where it stops. What I'll be showing you soon is how you can actually put sensor systems, big data, and analytics on top of this network in order to start adding more capability. Dr. John Sotos and I did not correspond in any way about the talks, but he was actually talking a lot about this in his keynote presentation. And then John Glasser was also building on this fact with the population health management. That it's kind of interesting to me. He was building on that to do this. I'm building on this and adding that on top of it. But they're really the same thing. And then finally, you can add these new tools and technologies like machine learning and augmented reality in order to further build onto this one common network. And then that's going to go on and on, I think, for a while, because there's lots of exciting things to do here. So what I'm going to do now is I'm going to share with you 3 examples of how we can start actually going up step 2 and step 3 in hopes to kind of open your perspectives such that especially the physicians and the clinical experts in this room say, hey, I could use that. I could use it this way. I could use it that way, et cetera. So my first example is around thermal imagery. And it turns out that back in 350 BC, Hippocrates was the first physician to use thermal imagery to examine a patient. What he did is he actually took mud and he put it all over a patient, and then he observed that where the mud dries faster, as in the patient is warmer, he thought, hey, perhaps that's where the disease is. Quite interesting, quite ingenious at 350 BC. Fast forward 2,000 years, okay, now we start creating infrared cameras. Infrared cameras are like silicon cameras for video, but they're just tuned to a different spectrum of effectively light, and they sense heat. Now, these infrared cameras have been around for a few decades, okay, but they've really been in the only place they've been really used effectively or prolifically is in the military for and we've all seen night vision goggles. We've seen examples where you can use thermal imagery to see through walls so that you can see if there's people or hot things on the other side. And that actually helped tune the technology and drive it to where now it's being driven down to where thermal cameras can now be bought for under $1,000. The other thing which is driving this is other mass market applications. For example, there are car manufacturers now who are starting to put infrared cameras in the grill of the car so that you can actually, when you're driving at nighttime, you can see if a deer's about to cross the road or something like that. So when the thermal imagery cameras now get to a few $100s, you can start seeing about how you can incorporate that kind of technology into a telemedicine interaction such that it can be used in everyday medical use. So in order to illustrate this, I'm going to say one more thing before we illustrate this, and that is that you might say, where is thermal imagery applicable? So I'm just going to give you one example right now, and that is if you think about diabetes. Diabetes, as we know, is a huge problem. 10% of the US population, 30 million people. In a decade, the CDC says that China is going to have more diabetic people than the entire US population. The statistics are $5,000 to $10,000 per year is spent on medication for diabetic patients, and it's about $250 billion a year spent. And we also know that if you don't take care of it and if it turns into peripheral vascular disease, you can have these kinds of problems which affect other areas of the body, for example, the lower extremities. And these lower extremities, if you don't take care of it or detect it soon, you can have problems like neuropathy, gangrene, ulcers, and even amputation. Okay, so what I'd like to do now is to ask my colleagues to come out here and share with you how we might be able to incorporate thermal imagery easily and effectively into everyday clinical use. So I have a couple of my colleagues here. This is Marco, who's our diabetic person here, who's actually our head of innovation, director of innovation, and then Paul, who works with him in the innovation group that we have at In Touch. And then we're going to ask Dr. Steve to come out and join us. While Steve comes out and join us, I can tell you, so one of the things just to let you know up front is that Marco is not actually a diabetic patient, but what he has done is that what we've done is actually we've iced one of his feet, okay? So this is real, but the only thing not real about it is that Marco is not actually diabetic. So, Dr. Steve?
Hi, Yulun, can you hear me?
Yeah, I can hear you very loud and clear.
Great, thanks. Thanks for inviting us out here. Appreciate it. So I've got my patient here, Marco, and I understand that you've been complaining about some numbness in your legs. Can you tell me about that?
Yeah, doctor, my foot, it's been kind of numb and tingly recently, and I've had some trouble walking.
Okay. Can you prop your legs up for me
Okay.
so I can take a look? Great.
Sure.
Okay, let me zoom in on that. Okay. So you say that this started recently?
Pretty recently, yeah.
Okay, great. I don't see anything superficially that would, lead me to believe that you have a problem with that. So I'm going to switch to our thermal camera mode and see what that tells me about your condition. Okay, and let me adjust my temperature range here. Yeah, so we've pretty obviously got a temperature difference here, and what I can do is look at that through some different views. I'll go to my favorite one here.
So, Dr. Steve, what you did is it looks like you just hit a button and it converted you over from one camera system to the other. Is that what happened?
Correct. Yes.
Okay.
So, and it's built into our system there, and it's just like using any other auxiliary camera source. You can just click on it and access the capability. So let me adjust this, take out a little bit of the background. Good. Okay, and let me get some measurements here from your foot. If I look at
that foot doesn't look that good.
You're right. I know. It looks rather cool.
And what are you doing there?
And in fact, there's about a 7-degree plus delta between the two. So I can look at different parts of the foot and compare those differences, and I could even record and track those. So there's less of a difference down here.
Are we going to have to amputate?
Well, hopefully we'll get ahead of that, but I'm very glad that we've caught that early because I believe it's related to your diabetes, Mark.
Okay.
Oh, can you explain that a little more?
Yes, so diabetes can have complications that are left untreated, can lead to severe problems, like ulcers and even gangrene in a severe case. But we'll have follow-up with you and treatments and prevent that from happening. So I'm glad we caught this as early as we did.
Wow. Okay, thank you, doctor.
Thank you.
Great. Thank you, guys. So you guys, you can see how easily you can just incorporate a telehealth interaction where you can just do the thermal imagery of a patient, just like that. So what are some different use cases? And I use these just to kind of stir the creative engine in each of you here. It turns out in 1982, the FDA actually cleared doing thermal imagery in concert with mammograms in order to determine the possibility of breast cancer. And then in 2010, Johns Hopkins actually started a pilot study where they were looking at pigmented skin, and they were trying to use thermal imagery to see if that pigmented skin was just a benign mole or it was some type of skin cancer. And the idea is that if it was skin cancer, it would be a little bit warmer. And I think that work is still ongoing. And then an area that we all know very familiar with here is the possibility of preventive stroke. And so, as we know, that occlusive disease, if it starts shutting down the carotid arteries, you actually have a higher risk of stroke. And it turns out with a thermal image, you can actually see if the carotid artery is a little bit occluded or something like that in just a normal primary care exam. And in doing so, you can actually take preventive action right out of the gate. And then last but not least, pediatrics. We had a whole panel this morning and a great talk on teleneonatology. What if you're able to just, in any of those examinations, quickly flip over to a thermal image? I'm sure it would give the neonatologist that we had on stage earlier today more information about that patient. And then furthermore, neonate babies often have tissue thin skin. And so anything you can do where you don't have to contact the baby directly is actually helpful to them. Okay, so that's example one. Example two. I think we all know that as part of any type of examination, what clinicians do is take the vital signs of a patient. The respiration rate, the blood oxygen level, the blood pressure, the temperature, the pulse. And with the assembling of this data, together with the interaction of the patient, can actually render diagnoses. 2 years ago, when I gave that talk from flesh and bones to bits and bytes, I took snippets of a TED talk of a Dr. Michael Robinson, who was at MIT, and he had developed this technology called a motion microscope. And in a motion microscope, what the technology is it takes a video image and it amplifies a changing variable within that video frame. So what he showed in his TED Talk is that if you play a video, this was his child, if you amplify the motion on the left to be seen like on the motion on the right, just by looking at that baby, you can not only see the baby's breathing, but you can also tell the respiration rate. And then another clip he showed in the video was of this gentleman's face. So that was a motion amplification, but the motion microscope can actually be used to amplify other variables, as I mentioned. And in this video, he took the source on the left and he applied the motion microscope to the right, and you can actually see the pulse because of the minor changes in facial color that are happening that we can't see without the amplification. Now, this technology is continuing to be worked on, and in fact, this is actually a little video by a PhD candidate, Wang, who's at the University of Eindhoven in the Netherlands. And you can see through this video here that he's actually making this motion microscope more and more robust. You see a pulse trace, you see actually the facial pulse, and you can see it's even robust enough to handle his motion in the frame and keeps it going in the frame. So once again, I'd like to ask my colleague, I'm calling him Dr. Steve, but he's a co-founder of the company, and he's the vice president of our technology, and he's not a doctor. But he loved the opportunity to wear a white coat.
Oh, yeah.
And so I'm going to turn it over to you again.
Great. Thank you very much for letting me up here. So what I wanted to do was show you guys by beaming in through our normal provider access software with nothing but a camera. We'll be able to take someone's pulse remotely, in this case, my patient or victim. So let's give it a try. Is that showing up? OK, good. So we'll be logging in here. And there he is. Hey, Paul, how you doing?
Hey, Steve. Doing pretty good.
OK. And can you guys hear that?
Yep.
OK, good. And so, Paul here is volunteered to work with me on this. And what you're seeing is our normal provider access interface. And up here in the left, you'll see a new button that you haven't seen before. And this will allow us to look at his pulse rate. So I'll turn that on. And there's a few things that I'd like to show you about this. One is that green square around his head, and that's not to make him look funny, but it's actually the software looking at the incoming image and frame by frame determining where his head is. And so as he moves to the left and right, it will track that. And so in a normal exam, people are going to move, so you have to be able to do that to keep the area of interest in focus. And then so what it's doing within that square is looking at the subtle changes in hue that are happening that you couldn't detect by looking at it, and then it's plotting them down here in the lower left. And although he said he was nervous, I think he was really nervous. Usually he's quite a cool customer, so I think maybe the Red Bull got to him this afternoon. But I think you guys get the idea. So thanks, Yulun.
Paul, it's okay. We're almost done here. Okay. All right. All right. Thank you for that.
Thank you.
So, telehealth encounters, one of the barriers to doing a great encounter has been the lack of an ability to easily get vital signs and other clinical information. But what I've just shown you are some examples where actually just by logging on and seeing the patient, I can know their respiration rate, I can know their heart rate, I can know their temperature, and you can see how we can start knocking off those vitals one by one, which is just embedded in the fact that technology, it just inherently does it. This motion microscope technology is actually being in the process of being commercialized. There's a company called Oxen Health, which is a spin-off out of Oxford University in the UK, and they're working hard to make the motion microscope a commercial reality. And I forgot to mention earlier that this thermal camera work is work that we've been doing, and we are pushing that into our endpoints in the not very distant future at all. So that will be coming out into our platform. Let me move to my third example. And the first two examples are really about kind of improved diagnostic capabilities. This is kind of a different tact, okay? This is a different area. It was last year that the AMA published a report of how physicians spend their time. You'll notice in this, about a quarter of their time, they have the opportunity to spend it on what they actually enjoy doing, which is taking care of patients. And you see that about half the time, they spend on documentations and interacting with their EHRs. And this is, no mystery to anybody here that this is not only a cause for a certain amount of inefficiencies in the health system, but it is also something which has been ascribed to things like physician burnout. About 1 in 3 physicians, they say they're experiencing physician burnout at any time. So, and then furthermore, a physician who's not, is feeling burned out is actually also has challenges in actually performing at the highest quality of his or her level, and therefore medical errors go up as well. So I think you've heard in many different talks today the term AI, machine learning, deep learning coming up. And I think there's a reason for that's coming up over and over in this conference, is because it's very clear that a telemedicine platform is a perfect kind of platform to apply this new technology on. And so what I'm going to now talk about is also how to use AI or machine learning in order to help solve this burnout problem. We can try to minimize or even eliminate that 45% of the time. And then there would obviously be improvements in the quality scores as a result of that as well. Now, Dr. John Sotos did an excellent job earlier today about explaining what AI is, or machine learning, but I don't think it's too repetitive to also share with you another slide, which is, this is the best single sentence I've been able to find to describe machine learning. And that is, machine learning is a type of artificial intelligence that provides computers with the ability to learn without being explicitly programmed, and can grow and change when exposed to new data. And then furthermore, what we also know is this area is very hot. A huge amount of resources are being put into it. You know, we've all heard of IBM Watson. There's Google, Amazon, Microsoft, Facebook, all putting a massive amount of energy into machine learning, and on the order of billions, okay, of dollars. So these are big deals. And then it turned out I just happened to have the same earlier stage company that Dr. Sotos had in his presentation of HeartFlow, but there's a plethora of these companies who are applying machine learning strategies in healthcare. And in fact, in this CB Insights market research report, which just came out last year in 2016, it shows that healthcare is the top area where artificial intelligence and machine learning is being applied. So if we think about our telehealth encounter, okay, and we go back to the paradigm that's where I started this talk, from flesh and bones to bits and bytes, and we go back to the point where there is a technology interface between the physician and the patient, and that technology interface is connected to a computer. What we now know is that that computer is observing the entire video interaction, both ways, between the physician and the patient and any other people in the interaction, and then also able to digest the dialogue that's going on between the clinician, patient, and anybody else who's in that interaction. So what I'm going to share with you now is a video that we created, and it's a vision for InTouch that we're working hard to pursue, and it's the usage of artificial intelligence to create an automated soap note, okay? What you're going to see in this video, on the right-hand side, you're going to see Dr. Rogov as the physician. You're going to see the patient and the nurse in the middle interacting with Dr. Rogov. And on the left side, you're going to see, we call it Al, okay, for the AI. And Al is actually processing what Dr. Rogov is telling it to do, and also observing this interaction. So let me share with you this video to kind of share with you what this concept might look like.
Al, let's get ready for consult. Can you bring up all the consult views, and let's take a look at all the scans for the past 10 years and put them in chronological order. Okay, that's fine. Let's see if the patient's ready. I'd like to do the consult right now.
Hi, Dr. Rogoff. My name's Betty Cooper, and I'm your physician assistant today. Let's meet our patient.
Hi, Betty. And hi, Mike. My name is Dr. Rogoff, and I'm your teleneurologist. And Betty and I are going to perform an examination on you right now. So let's start with giving me your full name and your date of birth.
My name is Michael Scott, and my birthday is September 7th, 1958.
Excellent. Thank you, Mike. Now, I'd like you to open and close your eyes. Very good. Now, I want you to follow Betty's finger. She's going to put her forefinger up, and she's going to move it from right to left and left to right. Very good. Now the next command is for you to show me a big smile. Okay, Mike. Now the next test will be for you to squeeze with your right hand Betty's arm.
5 out of 5.
Okay, let's try it with your left hand.
About a 3 out of 5.
3 out of 5? Okay. Okay, now I want you to raise with your palms down your right arm. Good, Mike. You can put it down now. Okay, now I'd like you to try it with your left arm. Okay, Mike. You can let that down. I know it's a little bit weak. Now we're going to try the same thing with your lower extremities. So with your right leg, can you give me a lift? Very good. You can put it down now. Now let's try the same thing on your left leg. Okay. That's fine, Mike. I understand. Now for the very last question, I'm going to ask you to read on the screen the sentence that appears.
The quick brown fox jumped over the dog.
Okay, Mike, that's the end of the exam. Ms. Cooper, I'll have the report to you within a few moments. Thanks so much, everybody.
Receiving it now, Doc. Thank you.
So for the doctors in the room, how would you like it if at the right at the end there, your documentation is done? So let's go back over some aspects of that video. So first of all, speech to text. I think actually, as Dr. Soto's mentioned during the keynote, the speech to text capabilities of machine learning has already hit the level of human comprehension capability. Once that happens, it's only going to get better, okay? So we're at the human level here already. Clinical information. Dr. Rogoff was able to directly talk to Al. It's a little bit what Dr. John Glasser was talking about earlier, where now it's able to pull together all the different pieces of data which pertains to that patient automatically. Facial analysis. If we remember Dr. Soto's talk today, speech recognition and image recognition are the two areas where the technology shines, okay? So determining, first of all, who's who is one thing, and then using image analysis to actually determine things like, okay, the left arm or the left leg not lifting up as high as the right leg. Again, Al would be able to see that. And then voice analysis, such that it's not just speech to text, but it's actually detecting things like slurred words and stuff like that. And then last but not least, this consult, assuming, is being built on top of 300,000, 400,000, 500,000, 1 million other previous consult notes of the same type of interaction, so it roughly knows what the input and the output should look like in this kind of scenario, and then an automated SOAP node is already created and stored wherever it needs to go. So these are the kinds of things, I think, which are possible. So I gave you 3 examples here. The infrared is actually very soon. We're working on the commercialization pathway now. The motion microscope is a little further, but not that far. Startups are being formed in order to build this out, in order to commercialize this. This kind of automated SOAP note capability, is actually something which is, my opinion, it's single-digit years out, okay, as in less than 5, the kind of things which are possible. And so it turns out, to finish off this talk here, every once in a while there are these new technology platforms which come around, and they are used in a myriad of ways to build new industries and capabilities. Edison invented the light bulb in 1878. It didn't just light the inside of buildings and provide light where we needed it, which was a big deal unto itself. But, for example, it started the movie industry because it was able to project. It's responsible for a lot of the consumer and the electronic industry as we know it today. Something a lot more current is like the iPhone. We use the iPhone. We actually use it to navigate. We use it for our social media. We use it for even wellness applications for health. And as we know, Apple's doing a lot on that. But we also know that Apple isn't the one who's driving all those different applications built on top of their platform. And this is where we get back to the title of my talk, is telehealth a platform for physician-led innovation? It is the clinicians and physicians in this room who really understand what healthcare is all about. You know, in touch we don't, and we don't claim to. We actually are pretty good at the technology that we develop, but it's really going to take the clinicians in this room to take these kinds of capabilities to work on solving these big problems like physician burnout, physician shortages, disparity of healthcare, cost, patient convenience. And I think that with the collaborations that we can work together on, I think that we can actually move forward over the next decade, solve these problems, and build a healthcare system that we're all proud of. Thank you very much.